So the other day at InVision, I had to fix a bug where a user could drag a screen up and down within the document, and as the user approached the edge of the viewport, we needed to scroll the document up and down automatically so that they could move a screen to a position that had not previously been visible at the time the drag started. And this is not an area of DOM manipulation that I'm particularly comfortable with or super familiar with, and there's some cross-browser quirkiness. So I wanted to try and break that out into its own demo, mostly as a note to self for my own future reference. So what I have here is a grid system, and you can see I can scroll with my mouse wheel up and down. You can see the grid moves, and it can go left and right as well as up and down. And this red border here is the edge of the is the delineation of the edge of the viewport. So as I move my mouse into this edge area, what we're going to do is automatically scroll the window in the direction of the mouse. Now, I'm already at the top left of the document, so there's no scroll, but you'll see that as I move into the edge on the bottom, we're going to start to scroll the window down. And as I move closer to the edge, what you'll see is the velocity of the scrolling will actually increase, so that the intensity of the increment there matches the closeness with which the user gets to the edge of the document. And I can scroll in both directions here. You can see I can scroll to the right as well, and if I scroll back into the middle, of course it stops. Once I go back into the edge, you'll see that we again continue to pick up speed with the velocity of scrolling. I can scroll two directions at the same time, and again, as I move closer to the edge, the intensity of that scrolling increases in proportion to the closeness with which the mouse is to the edge of the viewport. So again, this is not an area of DOM manipulation that I'm terribly comfortable with, so again, I just wanted to break this out as a note to self so that I could reference it in the future. If we want to take a quick look at the code, to keep things simple, all I have is a mouse move event handler, and pretty much all of the logic, less the drawing of the grid, is contained within the handle mouse move event. So what you can see, well, first off, I want to call out JavaScript Info because JavaScript Info has all of the information about the cross-browser quirkiness of gathering dimensions and offsets and setting offsets of things like the window and the document, which don't necessarily follow the traditional element-based offsets and dimension rules. So again, I just don't have the capacity to keep all this information in my head, so I find myself going back to JavaScript Info time and time again. But essentially what we want to do is get the viewport relative coordinates, so where I am in the screen itself, not in relation to the scrolling document, but within the actual physical browser window here. What is that x and y coordinates? Then I want to figure out what the width and height of the viewport is as well, and now I can start to determine how close these x and y coordinates are to the edge of this viewport. And you can see I try to break all of these intermediary calculations out into their own variables so that they become a little bit easier to understand and a little bit easier to work with. So again, I have a 200 pixel edge, right? That's where the red border is here. It's 200 pixels from either side of the viewport edge, and this area is my edge zone, so to speak. And you'll see that I'm essentially calculating the offsets of the various borders of that edge. So my edge top is 200, my edge left is 200, my edge bottom is going to be the height of the viewport minus that edge, right? So we want that bottom is the total height minus the size of the edge, and similarly the right is the viewport width minus the edge size. Now I can calculate whether or not the mouse is in any one of these edges, the left edge, right edge, top edge, bottom edge, so on, by looking at the mouse coordinates relative to the edge location. And if I'm not inside any of the edge locations, then I can simply return out because there's no further calculations that I need to take into account. If I am in one of the edges, now I need to take some actions, or some potential actions. First, I'm going to calculate the document width and document height. This is the full height of the document, regardless of what's actually inside of the window scroll. Now you'll see there's a whole bunch of math maxing here, and again, this is what I got from the JavaScript Info site. This is all the cross-browser quirkiness. The Info site explains it a lot better than I can, but essentially we have to look at all these to make sure that in each browser we're getting the actual document height and document width. Then I calculate the max scroll, which is essentially the portion of that document that is not contained within the viewport. And at this point I need to set up some sort of an interval, because not only do we want to move the document as I'm moving the mouse around, but if I stop moving the mouse, as I have done at this point, we want to continue the window automatic scrolling in the direction of the mouse. I don't want to have to constantly move my mouse in order to create a scrolling effect. So to do that, we have to set up a timer. Now this is a what is it called? Immediately, what the heck does that stand for? Immediately invoked function expression, something like that. So I create this inner function here, check for window scroll. I'm immediately calling my adjust window scroll, and we'll look at that logic in a second. And this is going to return a Boolean as to whether or not window scrolling took place. If it did take place, then that means that there's potentially more scrolling that has to be done, and at that point I set up a timer. Otherwise, if no scrolling took place, there's no need to set up a timer. Now, here's where all the scrolling logic takes shape. We get the current offset of the window, which is in this page X offset, and I think there is like a page X and page Y, or maybe there's a scroll X and scroll Y, which are also aliases for this. You can look that up in the Mozilla Developer Network. I'm not sure if there's cross-browser compatibility issues there. I check to see if I can scroll in any particular direction, which means that have I reached a maximum or minimum scroll in a particular horizontal or vertical scrolling direction. Then we need to figure out what our next scroll will be. So I'm going to start my next scroll equal to my current scroll so that I can start to change these independently, but more importantly so that I can then compare these values at the end to see if any scrolling delta needs to be implemented. Now here's where it gets a little bit interesting. So if you remember, I said that we want to scroll when we cross into the edge, but we want the intensity or the velocity of the scrolling to increase as I get closer and closer to the edge, right? As you can see it's doing. So the way we're doing that is calculating the sort of percentage of overlap my mouse has with the edge, and we're calling that intensity. And you can see that I'm taking the intensity and I'm multiplying that by the maximum step for each scrolling delta, and then I'm using that kind of partial max step to either decrement or increment the next scroll in each of the directions. So I'll just leave you to look at that math, and then I adjust for some minimums and maximums to make sure that this next calculation makes sense. Because if the next scroll equals the current scroll, then there's nothing to do, right? Where the logic above has not given us any steps to take. But if either of these values are different, then we know that we can scroll to the particular calculated location. In that case, we're returning true, which again allows us here to then set up a timeout to call this method again in 30 milliseconds. I'm sure there's a more elegant way to do this. Maybe there's some sort of a animation frame, something that takes timing into account a little bit more and does some more time-based calculations. But really the point of this demo is not the how often do I check this method. The point of this demo is really when I check this method, what do I have to do and how do I calculate all this stuff? And this is the things that I can never keep in mind, or I can never keep in my mind. So I wanted to break it out so that I could refer to it later. And that's pretty much all there is. The rest of this is just setting up the grid lines so that we can see that the document is actually scrolling when I move the mouse and the intensity with which the window is scrolling. So again, note to self, primarily for my future endeavors, but if this helps anybody else, then that's just gravy on top of that.